One back. The world needs to move away from fossil fuels, not only to combat climate change, but to supply affordable energy. I'm Matias Sigal from Wave Power, and I would like to tell you about an overlooked source of green energy, wave energy. Wave Power developed an innovative technology to harvest the power from the ocean and sea waves. Our solution is unique, and by bringing the technology to the shore, we can reduce the capex at least 9 times comparing to other wave energy technologies. In addition, we have a great momentum, operating 2 wave power stations with more than 320 megawatts in project pipeline worldwide, and we recently made IPO in Nasdaq US this year. We have a strong intellectual property portfolio with more than 17 patents and patents pending, protecting our technology. We all know that today, around 80% of the energy comes from fossil fuels, and this is one of the causes of climate change. And wave energy can be part of the solution. Wave energy has a lot of advantages. First of all, most of the people in the world live close to this energy source. They live close to the coastline. In addition, wave energy is stable, and in suitable locations like UK, United States, or Australia, for example, can supply 24/7. And waves contain much more kinetic energy than wind, so we can produce the same amount of electricity with smaller devices. The problem is that in the past, most of the companies installed their systems in the offshore. Here we have an example. It's actually a Scottish technology that they went to the offshore, maybe around 5 kilometers out from the coastline. And because of this, we can face low reliability. There are waves that can reach 20 meters in the offshore and destroy these systems. But also we can face high prices because of the capex of a robust equipment, the O&M, the operation and maintenance of going to the offshore with divers and boats. For this reason, they were not insurable by insurance companies. But also, they were not so good for the environment because they attach to the ocean floor, producing some impact for the marine life. We brought the technology to the shore. So with our technology, we attach floaters into existing man-made infrastructures like piers, jetties, and breakwaters. It works like this. The floaters move up and down with the motion of the waves, making a piston compress an hydraulic fluid, which goes into an accumulator, creating pressure that turns an hydraulic motor and turns a generator, producing clean electricity. As you can see here, only the floaters are touching the water, and everything else is on land, completely safe from the water environment, inside a standard container. So because of this, we can be reliable. We have most of the system located on land and only the floaters facing the water, and we also have a storm protection mechanism. So when there is a storm, the waves can lift from the water level, as you can see here in the video, and protect from that storm. It's fully insurable by well-known insurance companies. It's cost-efficient and 100% environmentally friendly, which at the end of the story is our goal. So we're operating right now one project in Jaffa in Israel. This project got recognition from the Energy Ministry of Israel as a pioneering technology, and now we are expanding it in joint venture agreement with EDF, the French national electrical company. We are also cooperating with Siemens for the electrical part of the system. In Gibraltar, we're operating, which is the only wave power station in the world connected to the grid through a PPA, a power purchase agreement. And we have a project pipeline of more than 320 megawatts worldwide. For example, last year we signed an agreement with APDL, which is a port in Portugal, for an up to 20 megawatts project. So the goal then is to start to build bigger power stations. That project will be done in phases, starting with a smaller install capacity. So this is part of our project pipeline. As you can see, we are interested in different countries around the world. This includes different kinds of agreements and collaborations in different stages. But now we are here, and the UK has immense capabilities for wave energy. You can see here the wave map. So the wave map is showing that approximately there are waves between 1 meter height and in sometimes 3 meters height. And with this, we can create significant amount of electricity. In fact, the government of the UK estimated that they can supply approximately 20% of the energy need from the waves. This will mean a new industry with thousands of jobs, they are saying tens of thousands of jobs, and billions of pounds in investment. And this will also help to reach a net zero. So here, I'm opening to you an opportunity to make a step for a more sustainable future. We are looking to collaborate with landowners like ports and councils, with strategic partners like energy companies, and with project investors. And this will help to reach an energy transition. Thank you.
Matias, thanks very much.
Thank you.
Again, a fascinating few case studies in this area. I've got a couple of questions, but any questions before I fire in with a couple? So I'm quite interested in terms of kind of the value for landowners. Do you foresee you mentioned about your partnerships with kind of EDF and Siemens, but is that because they own the land, or is that on someone else's land? And how do they? Where's the kind of the revenue generation for landowners in this?
Yeah. Thank you, Alexander. So, yeah, actually, our model for landowners is pretty interesting because we use a real estate that is a breakwater. The goal of the breakwater is to stop the waves, and we create value from that. So we offer, in this case, maybe a port or a council that owns this infrastructure, that we will deploy the system there, and we take care of the development of such project, and they get economical benefits from the use of that unused real estate. So, and in addition to that, they get additional benefits like being sustainable, being innovative, but mainly in this case, the economical benefit is from the real estate.
And do you see that is that part of the value proposition that you are presenting to people? Do you go out to sites and say, right, this is the feasibility of an eco-wave platform here is quite high. This is what you could do with this land.
Yeah, exactly. So that's our approach, and when we talk with landowners, that's maybe kind of the initial discussion. But yeah, at the end there are different kind of values for them, and it depends who is the landowner or who we are talking with. If we talk with someone that is also interested in producing electricity, then maybe the conversation is different.
And essentially, you chose NASDAQ to float. Why NASDAQ as opposed to any other stock exchange?
So, well, actually, we are right now, first we listed in NASDAQ Stockholm, in NASDAQ First North, and then we did an ADS, so we moved part of the stock to the US. So, yeah, because there is a lot of renewable energy companies doing really good in that space, and also marine energy companies in that space, so it was really good for our growth, and also in order to be able to develop projects.
Because one of the folks we had here yesterday, one of the kind of investors was helping companies float. It was only on the London Stock Exchange. So again, just interested about the nature of these companies that we have as part of our program, their trajectory for growth, and the opportunities and where they see their future development. Yes, Roberto.
Hi. Yeah. Thanks a lot for the presentation. It was very interesting. I don't know if you mentioned that, but is there any impact on the sea life when you implement this kind of stuff? How does that work?
So, thank you, Roberto. So, well, when we developed the technology, it was one of the parts we look at to not create an impact on the marine life. And because we attach the system to existing marine infrastructures like breakwaters, we don't create new presence because that presence is already there. So there is no risk for the marine life. In addition, we use biodegradable hydraulic fluid. It's kind of a detail, but also shows how we care of not making an impact on that side.
Guilherme.
Just out of curiosity, Matias, congrats on the presentation. Do you have it mapped already? Because I kind of understand that it's feasible to put in many places, but it's not feasible to put it in all places. By any chance, you guys have already mapped all your potential places? So say in Brazil, you see this and that area that might be of interest or in other countries of the world?
Yeah. So basically, like as a general rule of thumb, we look at sites that are exposed to the waves with existing marine infrastructures, like not landlocked, not blocked by an island. Answering your questions, we did site assessment for some locations. For example, in Scotland, we did a site assessment that we have it, and I'm really happy to discuss it if someone is interested. In Brazil, we also did. So we have some identified sites that we can discuss. So we don't have all the world, but we did when we have discussions with some parties that are interested in understanding that.
I mean, what was interesting, what struck me, in the same way you had the conversation around buses and electrification of buses, it's not just simply pulling out the batteries, but pulling out the combustion engines and putting in batteries. It's a whole change along the supply chain. And in the same way, this presents challenges and opportunities, but of a system of electricity generation, which is not from the inside and out, it's actually from the outside and in. And, and these are the challenges that countries will face if they're wanting to meet their net zero targets. But with that will come financing and the opportunities. Well, Matias, again, another fascinating presentation. Thank you so much, and as ever, thank you for making the effort to come over.
Thank you, Alexander. Thank you, everyone.